If you have a child in elementary school, you may have noticed that they are learning how to do math differently from how you probably learned. In fact, they may be learning lots of different ways of doing math. In this video, I will talk about a few of the different multiplication algorithms that your child may be learning. I'll explain them to you so you know how they work. I'll explain why your child may be learning those. And at the end, I'll give you some tips on how you can help your child learn to do this math without giving the whole thing away. First, we'll take a look at the standard algorithm. That's what we call the way that you probably learned to do multiplication. Our example problem for all of these different ways of doing multiplication will be 67 times 48. In the standard algorithm, we write them like this. Then we work from right to left, multiplying numbers in pairs. So the first thing we do is we do 7 times 8 is 56. We write the 6 down here and the 5 goes up here. Next we do 8 times 6, which is 48. But we have to add this 5 in up here from the 56 before. And the answer is 53. So I write my 3 down underneath. And since there isn't another number in my top number, we just put the 5 down. Next we multiply 4 times 7. And we're going to put our answer on a new row. 4 times 7 is 28. So we put the 8 down under the 3, not under the 6. We have to shift that over. And the 2 goes up where the 5 was before, so we got to cross that off. And we write a 2. Next, we do 4 times 6, which is 24. But we have to add in that 2, so we get 26. And then we write the 6 under the 5, and again, since there isn't another number in the top factor of the multiplication, we just write the 2 in the 26. Then we take these two rows and we add them up. So 6 and nothing is 6. 3 and 8 is 11, so I put the 1 there and carry the 1. 1 plus 5 plus 6 is 12, so 2 there, carry the 1. 1 plus 2 is 3, so 3,216 is the answer. Now, did that ring any bells for you? It sure did for me. Now, the standard algorithm has some pros and cons to it. Here's the list of a few pros. First, it's optimized for efficiency. This is a way of multiplying that's quite efficient. We can do it fairly quickly, too, once you learn the algorithm. And finally, we can do it without having to write down a whole lot of things. It's only a few lines and we can do multiplication. Hooray! Now, the standard algorithm also has some cons. First, this is an algorithm that's easy to forget. So many times as a math teacher, I see students forget to shift over that second row or the third row, or they forget what they're supposed to multiply. It's not very clear why this works. I'll bet if you thought about it, you'd have to think a little while about why this actually worked to multiply these. And it doesn't really lay a foundation for algebra. And that's what we're really trying to do with our elementary school kiddos. We want them to be strong in their number arithmetic so that when they get to algebra, when we start to abstract things and throw in variables, that they can recognize that we're not doing new things. We're just doing the same old stuff, but with slightly different objects. Instead of numbers, we use variables. Now let's take a look at a different algorithm. It's similar in some ways, but it is quite different. It's called partial products. Now again, we're going to use 67 times 48 as our example problem. But instead of thinking of 67 as one number, we're going to think of it as two numbers, as 60 plus 7. And instead of thinking of 48 as one number, we will think of that as 40 plus 8. Now, once we have these separated from us, we will simply multiply in pairs again. We will multiply 60 times 40. 60 times 40 is 2,400. Next we'll multiply 60 times 8. 60 times 8 is 480. 40 times 7 is 280. And last we do 7 times 8. So now we have a list of 4 numbers. We're going to add these up using our normal adding algorithm. So 0 plus 0 plus 0 plus 6 is 6. 0 plus 8 plus 8 plus 5 is 21. So I write the 1 down here and I carry the 2. 2 plus 4 plus 4 plus 2 is 12. So I put the 2 down at the bottom and I carry the 1. And 1 plus 2 is 3, and that goes on our bottom, 3,216. Now partial products might seem pretty weird to you. It might seem like a lot of extra work. But hidden in that extra work are a lot of ideas that are going to help our students make sense of algebra. Now, the partial products has some pros and cons, just like the standard algorithm. Let's talk about those for a moment. So here are a list of the pros. First, it uses prior base 10 number knowledge. Our number system is a base 10 number system. When we are learning about numbers in kindergarten and first and second grade, we learn about the tens place, the ones place, the hundreds place, the thousands place. And this uses those ideas and patterns found in multiplying multiples of 10. Another pro is that this makes sense. It's really the distributive property. So this is an algorithm where if you couldn't remember how to do multiplication, you could come up with this on your own. Another pro is that this lays a really strong foundation for algebra. I'll show you in a moment exactly where that connection is. Now there are some cons, of course. There's more writing, for sure. You have to write an extra couple of lines there. It takes longer because of that. And probably most importantly for you is that this confuses and annoys parents who are trying to help their kids learn math and don't understand why we don't just have them learn the standard algorithm the way they did. Now I said I'd show you the connection between partial products and algebra. So I want you to think back to your Algebra 1 class and your favorite lesson and mine on multiplying binomials. So let's take a look at this 67 times 48. Now that's really 60 plus 7 times 40 plus 8. If I write them sideways, I put them in parentheses like this, and then let's see what I did. So I did 60 times 40, and then I added 60 times 8, then 7 times 40, and then 7 times 8. Does this look familiar to you? If you paid attention in algebra, it probably should. This is our good old friend binomial multiplication. When I learned it, my teacher taught me the FOIL acronym to remember the order of things, first, outside, inside, and last, that we multiply. Yours might not have done that, but if they did, I know for sure that you know exactly what I'm talking about. Now let's take a look at a method of multiplying that's quite different from the other ones. It's called the lattice method. Here's how it works. We have our 67 times 48. So what we do is we make a grid, a 2 by 2 grid, and we draw diagonal lines going from northeast to southwest, upper right to lower left. Then we write one number going down on the right side and one number going across on the top. Then for each of the boxes in my grid, we multiply those numbers. We write the tens digit of the answer in the upper section of the box and the ones digit in the lower section. So 6 times 4 is my first. So 6 times 4 is 24. Then we do 7 times 4. That's 28. Next we do 6 times 8. And that's 48. And then we do 7 times 8. And that's 56. Now in reality, we didn't have to go in any particular order. we could have done 7 times 8 first if we wanted. And so sometimes kids will like this method because they can do the easy ones first, the ones that they remember best. Now, how do we get our answer out of this? Well, what we do, those diagonal lines are our key. We're going to add up going diagonally down to the left. So in the first one, we just get 6. Then 8 plus 5 plus 8 is 21. So I write the 1 here, and I put my little 2 next to that next row. So next I've got 2 plus 4 plus 4 plus 2. Well, that's 12. So I write the 2 there, and I put a little 1 for the next one. And 2 plus 1 is 3. Now, what we do to get our answer is we read down and around the corner. So 3216 is 3,216, and that's our answer. If you haven't seen the lattice method before, this is a pretty interesting and cool idea. Now, like everything else, it has its pros and cons. Here are some pros. First, it makes your problem into a series of one-digit multiplication problems, and it makes it really easy to figure out what things you're multiplying by what things. It works really great on problems with long numbers with lots of digits. You need to make a bigger grid, but it works really great because kids can focus on just one multiplication problem at a time. And since they can do that, it's easy for them to avoid making silly mistakes that they might make otherwise. Things like forgetting what numbers they're multiplying by. Some kids absolutely love this method of multiplying. I've noticed that it seems to be the kids who have a hard time with lots of other kinds of math, and this makes lots of sense to them. Now there are some cons, of course, too. First, there's more writing. You have to make this grid thing, and the grid can be quite big sometimes. It takes longer because you have to make the grid, and it's easy to forget how to set it up and how to work it because you've got one number on the right hand side, and it's easy to forget which thing goes on what side of the diagonal lines. That can be kind of difficult. But once kids get this, they really get this. Now, those are 3 different methods of multiplication. The standard algorithm is where we want everybody to end up, but we want them to get there in a way that helps them make sense of arithmetic. Kids who can make sense of arithmetic will be more successful in algebra because algebra is just arithmetic with numbers replaced with variables. So if your child is working on this math and they get stuck, or even if they're just working on this math and you want to show an interest in it, how do you actually help your kid? Well, first of all, don't just show them shortcuts. I know that you know these shortcuts, but when you show a kid a shortcut, they're going to focus on the little bits of that shortcut, and they're not going to focus on the big ideas. And that's what we really want them to focus on. Better than showing them shortcuts is to ask them questions. Questions like, hey, where did this number come from? Or, why did you decide to solve it this way? How sure are you of your answer? Does that answer even make sense? Or, this is different from how I learned it. Can you teach me how to do it this way? And then play dumb. Make silly mistakes that you're sure that they will catch you on. When our kids look out for our mistakes, it helps them look out for their own mistakes too. Ask them just to explain what they're doing to you. That's the best way to help them make sense of this. And above all, the best thing you can do to help your child with math is to show them how you use math to solve problems in your life. Show them how you use multiplication to figure out how much you have to pay the babysitter. Show them how you use division when you're trying to divide things up equally among them and their brothers and sisters. Or even better yet, give them the problem and ask them how to solve it. And let them solve the problem. Solving problems gives children confidence that they can handle what the world throws at them. That confidence will translate into a greater appreciation and understanding of math, and that is what makes math make sense.